All right, friends, today we're going to run through understanding significance. And it seems like it might be complex at first glance, but it really isn't. There's not a whole lot to it. I'm going to give you the crash course on this one with regard to the explanation and then also an SPSS. So if you think of significance as really just the chance that you are wrong in your statistical analysis, right? Obviously, we want to keep that as low as possible. And that's what I want to emphasize to you, is we want significance to always be very low. It sounds counterintuitive because we're raised to think, okay, well, I'm more confident, so I'm going to have a higher percentage. No. This is the chance that we are wrong. So we want to make sure it's low, and as you've read already in your textbook, we want to keep this below 0.05. Essentially, we want to have less than a 5% chance that what our analysis concluded was wrong, which means if you look at the flip side, it's essentially a 95% confidence that we are correct in what we run. So let me just show you a few different types of tests that you could run that include correlation so you get an idea of what it looks like and how to interpret it. So for example, if I was going to run correlation, let's have a look at correlation. So analyze, correlate, we'll go to bivariate, and let's take out, for example, let's do price in thousands and horsepower, because I know that positively correlates with, those two positively correlate to a significant level, and let's do width in there and see what that looks like. So if I throw all three variables in and hit OK. Right? In this case, so I've got price in thousands correlating with horsepower, and there's the R value, 0.840, a very strong correlation. If we look here for significance, this second line, if you follow it over, 0.000. Essentially what this means is not that you are completely confident. Don't misinterpret this. There is not a 0% chance that you are wrong, but there is less than a 1 in 1,000 chance you are wrong. Right? So you'll notice it doesn't say 0, it says 0.000. So basically what it means is there's not a number in the first 3 decimal places that would indicate you're wrong. So at the earliest, it would be on this 4th decimal place here. So there's basically less than a 1 in 1,000 chance that you're wrong. This is a very, obviously it's significant, and significance is binary, either significant or not significant, but this would represent a very high degree of confidence. Likewise, if we did price in thousands and width, we'll see the same sort of thing, right? So we see a correlation not nearly as strong, so price in thousands and width, 0.329, so a fairly moderate correlation here, but it is significant, 0.000 once again. If we run something else, for example, if we look at, let's get a correlation that's probably not going to be significant. Let's throw fuel capacity in there. Let's see what that does. That's got to be a little bit odd of man out. But no, that's significant too. That's just fabulous. Let's try one more. Let's do, we'll do fuel efficiency, because this is early 90s data, so nobody cared about fuel efficiency back then. And yes, all of these are significant too. Let's do a t-test. Okay, this kind of proves my point that we'll actually use this in a variety of tests. So if we do a, let's do a independent samples t-test. We'll do it by vehicle type, and I'm just setting this up. You'll see more about t-tests in another lecture, so don't worry about it if you're not following this so quickly. We'll do price in thousands, like so. And what I'm doing here is essentially seeing if there's a significant difference between the price of cars and the price of trucks. Okay, here we go. Okay, so what we find here is the average car costs about $27,500, almost $28,000, right? The average truck in this data set costs about $26,000, $26,300 as it were. So there's not a substantial difference, less than $1,500 that separates the two. But if we look down here, once again, we're looking for the word significance, right? If we look down here, the significance is 0.585, right? So about a 58.5% chance that we are wrong. And that is completely unacceptable. Keeping in mind, we want to keep our chances of being wrong less than 5%. And we're nearly at 60% chance of being wrong in this case. So we would, in this case, reject the hypothesis that these two types of cars are different. The cars and trucks are different in price. Right? So when we're interpreting significance, keep this in mind. Significance is binary, so it either is significant or it's not significant. And we want our significance, as always, to be below 0.05. Let me be clear. If it's 0.05, it is not significant. It has to be less than, not less than or equal to, less than significance. Excuse me, less than 0.05 to be significant. And if it's 0.05 or greater, it is not significant. And the nice thing about significance is that standard will carry you across all sorts of analyses. I just showed you in correlation and t-tests, but you'll see that in regression. You'll see this in ANOVA. You'll see this in multivariate analyses too. It is consistent. So keep that in mind, commit that to memory. One of the most critical things you can remember for this course is P is less than 0.05.